Welcome back, 8th grade learners, to today's Explainer. We're exploring one of the absolute most fascinating push and pull dynamics in our entire universe, the world of scientific systems. We're going to look at exactly how nature balances itself out, how things change, and most importantly, what your specific role is in all of it. Let's explore the incredible world right outside your window.
Okay, let's dive right into this. Hebrews 13:8 reminds us that Jesus Christ is the same yesterday and today and forever. This is our ultimate baseline. We have a Creator whose character is completely eternal, perfectly unwavering and unchanging. But you know what's so incredible about that? It's that this unchanging Creator designed a physical universe that is highly dynamic. It's constantly shifting, moving, and adapting. Today, we're going to contrast that beautiful, eternal steadiness of God with the wildly changing natural world He designed us to study and steward.
To get our minds in gear for a second, I really want you to think about this question. What do a beautifully balanced coral reef, a forest slowly recovering after a wildfire, and a massive, sudden volcanic eruption all have in common? I know, it kind of sounds like a trick question, right? Because some of those sound so peaceful, while others sound incredibly destructive. But the answer is that they all represent the continuous, epic battle between stability and change. Every single environment on Earth is caught in this exact tug-of-war.
All right, Section 1, Stability and Change. Before we can even begin to understand how environments break down or shift around, we need to establish a baseline. What exactly makes an environment stable in the first place? Well, here's a definition you'll definitely want to jot down for your homework. Stability is when conditions in a system stay relatively constant. But listen closely to the second half of that sentence, often due to balancing processes. So the crucial point here is that stability is not just sitting still doing nothing. It's a highly active, ongoing balancing process. Think about standing on one foot. You might look totally stable, but your muscles are constantly making all these tiny, micro-adjustments just to keep you from falling over. Nature does the exact same thing.
Now, why should an 8th grader actually care about any of this? Because understanding these systems has massive real-world stakes for all of us. Recognizing what keeps systems stable and what forces cause them to change is the exact knowledge scientists use to protect fragile ecosystems. It's how engineers design reliable technology that isn't just going to fail when the environment changes. It is also how we predict future shifts in our climate and our resources. Honestly, monitoring these systems is quite literally how we keep our planet and ourselves safe.
But here's a totally counterintuitive truth that actually trips a lot of people up. Stability isn't always good, and change isn't always bad. Think about it. If a factory is pumping out high levels of pollution, and those pollution levels remain perfectly stable, well, that is a terrible thing. The system is stably toxic. On the flip side, imagine a forest recovering after a devastating fire. That environment is undergoing massive, sweeping changes. New plants are growing, new animals are moving back in, and that change is absolutely fantastic. It's literally the healing process at work.
Moving on to Section 2, the Balancing Act. Let's look at exactly how nature pulls off this delicate equilibrium when things are actually working the way they're supposed to. Picture a thriving, stable coral reef. Just imagine this beautifully vibrant underwater city. You've got healthy, brightly colored coral structures, crystal clear water, and a wildly diverse population of fish swimming everywhere. Everything is existing in just perfect harmony. But remember what we said a minute ago, that harmony is no accident. It requires constant, active work. Now, what's really interesting about this is how that balance is actually maintained behind the scenes. Step 1. Predator-prey relationships. Sharks and bigger fish eat the smaller fish. If they didn't do that, the small fish would completely overpopulate and eat all the algae, effectively destroying the reef. So predators are absolutely crucial for stability. Step 2. Nutrient cycling. Waste products from animals actually become food for the plants in the coral. Nothing is ever wasted. Everything gets recycled. It is this brilliant, self-sustaining loop designed by God to keep the status quo perfectly in check.
Which brings us to Section 3, Sudden versus Gradual Change.
But what happens when that perfect harmony gets thrown completely out of whack? Outside forces are constantly pushing against the natural systems we just talked about. Here's a quick scenario for you. Imagine a perfectly stable lake. Suddenly, someone dumps a single bucket of fish into that lake, a type of fish that has literally never lived there before. How can one new invasive species change everything? Take a guess. Think about those food webs and how incredibly fragile they really are.
And this brilliantly illustrates the whole difference between sudden and gradual change. That bucket of invasive fish, that is a sudden, massive shock to the system. The new species has absolutely no natural predators there, so it just eats all the food, completely disrupting the lake's food web and causing native species to rapidly decline. It's an immediate shock. In contrast to that, gradual change like climate warming happens over decades. It's this slow, creeping shift that forces species to slowly adapt, maybe migrate to cooler areas, or gradually decline over generations. Both disrupt a balance, for sure, but at vastly different speeds.
Section 4. Why monitoring matters.
We've seen how delicate nature is, right? And we've seen how easily it can be disrupted. Well, this is exactly where human intervention and the scientific method play a hero's role. As scientists and learners, you aren't just passive observers taking notes while the world burns or flourishes. You have an active role to play. Scientists act as watchdogs. They actively monitor systems to detect the earliest, tiniest signs of change. They do this so they can respond before major, irreversible damage occurs. Like, if a forest is becoming way too dry, they might prescribe a controlled burn. They actively step in to help maintain ecosystem stability. They really are the guardians of the balance.
And finally, Section 5. Stewards of God's creation.
This is where we bring it all home and connect these scientific concepts directly to your deeper purpose. Here's your biblical morality tip for this lesson. As stewards of God's creation, we are called to maintain the balance He designed. You see, science isn't opposed to faith. Science is actually the tool God gave us to protect His systems and restore the ones that get damaged. When you're out there studying the food web of a lake or the nutrient cycle of a coral reef, you are literally learning the instruction manual for how to care for the earth you were put in charge of.
This is literally the core of the Heroesmart Academy philosophy. Education without morality will hurt. Think about it. What is the point of being incredibly smart, getting all A's in science, and being supposedly educated if you just go around making unspiritual, selfish choices that hurt the world and the people around you? An educated mind without a solid moral compass is honestly like a super powerful engine without a steering wheel. It's just dangerous.
But there's a really beautiful alternative here. Romans 8:6-7 promises true peace of mind to everyone who keeps their mind spiritual. When you align your incredible scientific education with a strong moral, spiritual foundation, you don't just gain knowledge, you gain real wisdom. You get to experience the amazing peace that comes from knowing you're responsibly applying what you've learned to heal the world, not harm it.
So, I'm going to leave you with this final, pretty provocative thought to ponder today. How are you going to use your education to protect the balance of creation? You understand stability now. You understand the difference between sudden and gradual change. You have the tools. So as a steward, what will you do with them? Thanks so much for joining me on this explainer, and keep exploring the amazing systems all around you.